Okay, from the notes, you should have gotten some just general characteristics of acids and bases. Acids have sour taste. They react with metals. In fact, they dissolve them. What you saw in the chemical physical changes lab when the acid dissolved the zinc metal. Reacts with carbonates, which is like baking soda. We'll get into more of that when we get to the next section, which is on dissolving acids in water and bases in water. For bases, they taste bitter. They feel slippery because really what it's doing is dissolving your skin, which is why bases are really good at drain cleaners. They dissolve hair, skin, soap, oil. What I want to go over in this one is what it mentioned in the notes about turning litmus paper red and turning litmus paper blue. And this is litmus paper. And this is probably one of the only times you're going to see litmus paper in a lab because it's not very accurate. But you can tell if it's an acid or a base. Okay, so I have, in order to test these three substances, I have to have both types of litmus paper. Okay, so I'm going to take the red first. Remember, red is acid, right? So I'm going to take my red paper. I'm going to put it in the acid. It stays red. I'm going to put it in the water, and it stays red. Okay, but then I put it in the base, and it turns blue. So that's why you need both pieces of paper. If I was to use, let's say, water, well, let's do it the other way. So I have base, I have blue litmus paper in the base, it stays blue. In the water, it stays blue. In the acid, it will turn red or pink. See, but the reason why you have to have both pieces of paper is if it's neutral, so here's my blue piece of paper, if it's neutral, no change, no change, it means that that is neutral, which is why you have to have both types of paper, because even though this stays red, doesn't necessarily mean that you have an acid. Okay? And if it stays blue, that doesn't necessarily mean that you have a base. You have to have both to test it to see whether or not it's neutral or not. Now, one thing I do want to go over, all the stuff online, they don't bother even using litmus paper. And again, it's just not accurate. It's just not very accurate. It tells you if you have an acid or a base, but it doesn't tell you how strong that acid and base is. So what I do have to go over with you, and I'll be going over it more with you in the next section, but in order to do the assignments, I need to go over something with you now. And that's what's called the pH scale. So the pH scale is a scale from 0 to 14, with 7 being in the middle. Okay, and these numbers, we can't go over them in much detail, but really what they are exponents of scientific notation, and it measures the concentration of hydrogen ions in a substance. But you don't need to know all that. You can get into that later. But 0 means an acid, and really what it means is the solution is completely saturated with hydrogen. Okay, 14 would be a base, and the way the exponents works, this is actually a really low concentration of hydrogen ion. Hydrogen ions is what makes an acid. If you dissolve hydrogen ions in water, you have an acid. The stronger or the more hydrogen ions there are, the more acidic it is. Anyway, so 7 is neutral. Okay, so if you have a pH of, let's say, I don't know, 5, that means you have an acid. Okay, and if you have a pH of 2, that acid is actually stronger than the 5, okay, because it's closer to the 0. If you have a pH of 8 and a pH of 10, this base is stronger than that one. Okay, so the closer you get to 14, the stronger the base is, and the closer you get to 0, the stronger the acid is. 7 being in the middle, which would be like water. Okay, so we do have a way to test pH with paper. Give me a second. So I'm going to go ahead and erase all this for now. What we can use is what's called pH paper. So I have some pH paper here. And what you can actually do, you can tell not only if it's an acid or a base, but you can tell how strong that acid and base is. All right, so I have my pH paper, and I'm going to put it into the base. Or actually, let's start with the water. So I'm going to put it in water, let it kind of soak around in there for a little bit. And what I get is sort of a greenish color, which would be right here. It's hard to see on the camera, but this color matches that, right? So that's a pH of 7. Okay, so that substance is neutral. We already know that it's water. Okay, so we know this is an acid, but we want to see how strong the acid is. So we use our pH paper, and I'll give it a little swirl. Okay, so that is more closer to the orange side of this spectrum. Okay, and if you look at the numbers, there's our pH. Okay, so we're about right here on the pH scale. We're at a pH of about 4, and that means we're on the acidic side. All right, so if I do it with the base, back that up a little bit. Do it with the base. And we have that color, which is about a 10 or 11. Ammonia is actually a pretty strong base. So remember, the closer you are to 14, this one doesn't go up to 14 because it's difficult to find a 14 pH base. The closer it is to 14, the stronger the base. The closer it is to 0, the stronger the acid. Okay, so with that, I've set up an interactive notebook assignment for you. So the first thing you're going to do is just copy this table down. Okay, so here's the table, and then go ahead and pause the video here, copy that down, and then I'll explain how to do it in a second. Okay. Okay, so here's my acid side, my base side, my neutral, which I've already done for you, and there's our labeling, right? This is going to be a pretty typical interactive notebook assignment. If you don't have colored pencils, just go ahead and draw that in, but I have the colors actually to match almost the colors that you would see on regular pH paper. So what you do is you just do a Google search, pH, and one of the first things is going to pop up is water. There's a few others, obviously, but then you just draw a picture that represents that thing. Okay, so pretty typical interactive notebook assignment. So next thing you would do, you'd Google pH of 6. What's an example of that? And then draw a picture that represents that thing. Okay, and that's pretty much it. Pretty straightforward. So an example of something for each strength of acid and base. Okay. If you have any questions, let me know through email. Bye-bye.